Hello everybody, I'm Alexey Krabarov, the AI community architect at Neo4j, and here we are at the GOS in Paris, the open source AI conference, and with me I have Arun Joseph,
Hi.
head of AI engineering at Deutsche Telekom. And before this main conference, we've been at a panel at the AI Strategy Day with Arun and Quentin from Clever Cloud, and we talked about the AI solutions, the applications, and I think there was a lot of very interesting takeaways, so we're going to cover some of this. First of all, Arun is the founder of the agentic framework called Elmos, and he talked about it and we discussed it at the panel. So, and I think it's really promising. So Arun, tell us a little bit about Elmos.
Sure. Elmos is essentially an agentic framework as well as a platform. So we coined it the term as an agent computing platform. All right, so what is an agent computing platform? So in 2023, we started an initiative in Deutsche Telekom. How do you bring Gen AI across 10 countries we operate in Europe? And it was pretty clear you cannot build applications chaining together prompts with the frameworks which were available back then. So we thought, let's build a new computing platform and constructs which might be the way our current engineers with their existing stacks can build AI applications. So there were two angles to Elmos. Let's build a framework which allows democratization of building AI applications for existing engineers who are on the JVM stack. Then there is also a platform side which accelerates the deployment, management, and lifecycle of these agents. The goal being this will help accelerate time to value. Mm-hmm. But then there is also another angle to it. We wanted to become like the Xerox Spark group, yeah? So when personal computing was taking off, Xerox Spark came up with several object-oriented programming and Ethernet and all that. So we came up with the idea, let's pioneer multi-agent systems. Let's build the protocols for interagents to collaborate. What would the future of distributed systems be? So this is another angle which resulted in a few elements like the Elmos protocol, etc., which we can talk about. Yeah.
Right. So what really struck me immediately as the very strong positioning of this agentic framework is basically it's based on Kubernetes, right? And so you just say kubectl get agents.
Yeah, exactly.
Right? And I just thought like this is amazing, right? Because Kubernetes is used almost anywhere now in the enterprise for distributed workflows.
Right.
And so you're treating agents as just one component of these workflows. Can you talk a little bit more about that?
Exactly. So the real challenges in developing distributed AI applications in any enterprise is how do you bring existing developers and also the stack that has already been built to put to use. Conway's law is not going away. If you start building, let's assume if you're an e-commerce company, you have all your e-commerce stack, product recommendations API, customer API. All of that is, let's assume, built in Java or Kotlin. And if you start another team which chooses the greatest framework out there, and then start to cobble it together, it's not going to work. Forget about it. Forget about whether the framework is the greatest or not. So this led to the first principle view that we should bet on a framework that our current engineers can understand, because there are these client SDKs which are already built, observability SDKs which are already built. Operations team has been managing Kubernetes clusters for so long. So why can't we start all over and start to build a stack which works with all these things, which resulted in a Kotlin-based framework with a DSL neatly, which allows existing engineers to do interesting experiments. This was step number one. So this is Elmos Arc. Then there is another angle to it. So our current runtime environments were entirely on Kubernetes. So you cannot build a new stack with the fancy platform capabilities of X framework for Y framework. Can a developer continue the workflow? Just git push an agent, and the next thing that they do, an ephemeral environment is spun up, and they can test the agent independently. And the operations team can monitor it with kubectl get agents, kubectl apply this to this channel, etc., etc. So this, as the first principle view, allowed us to create a foundation which accelerated the speed with which we were releasing agents across Europe, which goes beyond 3 or 4 countries, and we are expanding into 10 countries and handled already 3 million conversations and more.
Yeah. No, this was amazing. And they also mentioned that you don't need to Dockerize it. You don't need to put a VM around it, right?
Yeah.
You just have your agents.
Yeah.
Yeah, this is amazing. And basically, what struck me at this conference, right? There is convergence of all the enterprise technologies, right? So there was a Spring AI talk about MCP on JVM, right? And after we first talked, I saw there was a talk about proxies. So somebody implemented AI agent proxy in Rust, and they mentioned Envoy, right? So mesh computing, like all this stuff which was actually popular and useful. And we talked about Akka, right? Akka effectively is an actor system, and an actor is practically an agent because it encapsulates compute and data, and it can encapsulate your knowledge. And Akka has a very robust routing mechanism, which is failover and so forth, right? So how do you see kind of the existing enterprises? How can they leverage all of the existing expertise they have in their software engineering teams and add agents as a tool to the palette of things available to them?
That's a spot-on way to look at if you want to derive value. What stack do I already have, and what tools can we build to enable the existing stacks? That's the first principle view. So you talked about Akka, clearly more multi-agent systems. An actor-like approach is the only way it might scale because we are talking about natural language interactions between agents and also state management which might be locked within agents, just like message passing. In fact, fun fact, when we started Elmos, we started to model it based on the actor model, and there was a famous tagline, as in when I tried to recruit the engineers, is to say all the GPUs is a stage, all the agents are just actors. And also in the actor model, right? There is no one actor is no actor, and similarly one agent is no agent. So the interesting possibilities are going to come only when you break a big problem into smaller pieces which can collaborate and come to a conclusion. All of that went into what we built because we built not as a technical framework, but rather we were supposed to solve business use case, which is how do you solve for deflection rates? How do you bring up the net promoter score because people were so fed up with the traditional dialogue flow chat systems? So in a place like Deutsche Telekom, if you look at the domain, it's so vast. Billing, sales, there might be TV offering, there might be this offering. Customers might ask questions from anywhere in the telecom universe. And all of these, because of the way we have built the systems, might be independent CRM systems, independent APIs. Now, you cannot build one application with X framework and decide that it's all going to go away. So the way to approach that is let's create a billing agent. Let's break domain-driven design, right? So let's bring the TV query agent. Let's bring the escalation agent, and then put it all together and see what patterns can we observe. So the only measure is how do we build that foundation which accelerates for time to value instead of wasting time on wiring and plumbing and things like that, which resulted in the speed with which we are moving right now.
Yes, and it reminds me, right, that at our panel, I think we have you and Quentin, with a lot of experience in your respective domains. And so Quentin said basically from the cloud computing standpoint, it's the question of cost. Right, so AI is just another tool. We need to bring it in, and we need to bring down the inference cost. So a lot of users can use it as one of the other things. And you mentioned, in order to implement agents, you just need to speed up the development. So you need to do the time to value faster. Right, and basically that's kind of working back from the ad. You will derive the value. And so, also I was thinking about this, and I'm thinking that it sounds like yours is the only agentic framework, which I see coming from business. Right? A lot of other folks developed in a lab. Right? Like, let's imagine what an agentic framework might be like. Right? And that's amazing.
Exactly.
But you actually, you actually deploy it in the wild. Right?
Exactly.
And so you learn how to do it in the wild.
Exactly. So clearly, I'd like to touch upon that point. So in the past month, we started releasing agents built entirely by business. How is that possible? We were able to raise the abstraction layers gradually, right? And we rewrote several things several times. So we realized at some point, how do you define the requirements for these billing agent, right? There is no prescribed guideline. So once we started to build that DSL, then we started to build a prompt compiler, and then we came up with a new definition language for sales and service, which we call as the agent development language for sales and service. And now the business is able to write their requirements. For example, billing dispute. What should be the solution approach that the agent should take? And maybe in 2 days, it might not have worked the way they wanted. So immediately they can go in and then add another knowledge or a protocol to follow so that they can immediately test it, which reduces the time between raising a Jira ticket, going into a huddle room and all that. So clearly, all the learnings that we have had has come from the business requirements that we had. With only one measure, we knew that these systems are not going to be 100% deterministic. So we should have better ways to do experimentation and feedback loops in action. That's the only measure that you can bring into the design, and that has worked out so far well for us.
Interesting. So you have your own domain specific language.
Yeah.
How does it working out? Like, it's basically, is it for the non-technical people to easily formulate what the agents will do?
So there are two parts to it. So we have the Kotlin DSL. So we picked up Kotlin for two reasons. Our entire engineering transactional systems were in JVM.
Yes.
Right? And then we picked Kotlin because of its brevity, but then we also wanted an approachable way for these engineers without going for hundreds of courses to understand what the DSL is. It took a while, but a DSL came up like last year, and if you look at OpenAI, Agent SDK and all, it's an exact resemblance. In fact, I was talking to the Kanji team.
Yes.
This was the most
because they're on DSL.
The most pleasant surprise that I had. The lead developer of Kanji DSL said, 1 year back they searched for Agent DSL, there was nothing. A few months back they searched, they saw Arc, which is our agent framework.
Yes.
And the DSL development was led by Patrick Whelan, is a brilliant Kotlin developer. And he said he was inspired from the Kotlin DSL that we created from Arc, which inspired him to, because I looked at Kanji, the DSL looked a lot similar.
All right.
So he was sharing the credits also to Patrick. So one thing was the DSL for the generic programming. Then we realized, why don't we approach the same thing for business as well?
Yes.
Which is the prompt compiler because you cannot ask people to write prompt and expect it to work.
Right.
So we came up with patterns, we applied the same thing and raised the abstraction layers, which the business is able to write.
This is so amazing, because I was at Kanji talk, right? And I thought, this is amazing, right? People are coming up with new programming languages. I like programming languages.
Right.
And I asked also these folks, what makes you think that out of 10 million programming languages, developers will use this? Because he wants developers to use them, right? Developers have a lot of choices. And his most interesting argument was because it's Harmony OS. We'll support it. At Harmony OS, it will get. So it sounds to me like Swift for iOS, right? Because Apple puts everything in Swift. You will have to choose it for iOS and macOS programming. So and Kanji will get Harmony OS. What are you going to get behind your agent DSL?
Yeah, exactly. So the key part is, this was super. I had a discussion where a distributed mesh of agents, right? For example, we needed to define of course, there is A2A, multi-agent communication protocol, but like I said, in Elmos, there are two wings. One is a practical application wing, then there's also big bets wing.
Yes.
So, for example, we have developed a protocol based on WOT. Instead of building a new protocol, let's take Web of Things as a standard. And then why don't we apply the same technique that we figured out for device discovery and inter-device communication. So Robert Winkler proposed a brilliant idea to use WOT as a standard and build a multi-agent orchestration layer. So in fact, I had a discussion with the Kanji team, why can't we try it, right? For example, a device which is running Kanji, Open Harmony on a terminal, it can communicate with WOT standards, with Elmos protocol to an Arc agent, which is running on the Elmos platform through Open W3C standards. And these are some super cool things which the team has produced so far.
No, this is awesome. So I think to tie it all together, right? So we saw a lot of disruption coming in with Python ecosystem, which you had you thought it force you to reinvent the wheel. But now we see a lot of interesting tools which are coming from existing enterprise tools which are trusted and true, and observability and distributed systems and actors and spraying AI with MCP support, right, which makes it interoperable, and now OS support, right? So it's very interesting, right? So kind of suddenly everything, old is new again. Everything is useful. So kind of to advise enterprises who are looking at and implementing agentic workflows and looking around and like, why would they pick Elmos? What would be your advice to them? How can they best leverage the existing skills and teams to build agents with Elmos?
Yeah, exactly. So rule number one, start with your existing teams. What are they using? Because they know the domain. The largest part would be figuring out what is the domain knowledge or the API structure. So rule number one, check with the team who's actually built applications on top of which we want to plug in the agents, and then start with a framework. Step number two, instead of going after X protocol versus Y protocol, we build all of this without MCP or whatever. Why? Because we know the APIs. We will be able to construct an API which is a collapsed version of that API and build it for function calling, instead of setting up another server and new technicals to be learned.
Right.
And this is the quickest time to value. And if there is value which you're seeing, then start investing on scaling. Maybe MCP is required, maybe Kubernetes is required, maybe all these fancy evaluation tools are required.
Right.
So that is the practical approach, is go back to first principles, talk to your teams, educate them, and especially enterprises, they are on JVM stack. There is no need, I don't see any reason why anyone would, in their right minds, would reinvent the whole stack and create a multi-million other team, etc. Also, just one last point on this one. We saw several talks where agentic approaches are going. It's going under the hood into the platform.
Yes.
Responses API is a good example. Open Manus is the founder also mentioned, right? The model capabilities are going to determine a lot of these agentic capabilities.
Yes.
So I would imagine Responses API to be the future of platform API blueprint, which makes a lot of these agent frameworks a little bit of a bottleneck unless it serves some larger purpose, for example. So this is exactly the approach. For example, two people from the two of the co-founders from the Elmos team, they started another project called Open Responses.
Open Responses.
So which is a single Docker Compose. You can run a platform on your local machine, which exposes the same Responses API. It works with all OpenAI examples and OpenAI Agent SDK. And also we are integrating Arc to support this. It allows for an enterprise to attach tools under the platform, and your developers, you only care about the business requirements implementation, and the core of the platform is baked into the Open Responses with the idea you can plug in your own models, which can run on your local premise. So this is a most interesting project that I look forward to as well, because that's the future of agentic platforms that merges the model capabilities and the engineering capabilities under one API.
So that basically becomes like open ChatGPT with agents inside, presenting open responses outside.
Exactly.
And you control everything, it's on-prem.
Exactly.
You use your existing technology, use your company data, and you have freedom to choose different parts.
All right, that's a really good project. Open Responses is really something that I look forward to.
Fantastic. So my last question is, we're here at the conference. It's a developer conference, we have open source community. All right, and like all day we heard different talks. So what do you think the community can do? How would you invite community to work with you on Elmos to make this project successful?
Definitely. I mean, we have a Discord channel. It's Apache 2.0 licensed. It's under the Eclipse Foundation. So we have a really good backing by Eclipse Foundation, thanks to them. And there's a lot of European players also interested in the platform, because we built everything ground up, learning from actual applied AI, right? The other part is also, with protocol supports, etc. I mean, there's a lot that need to be built into Elmos. We look forward to contributions to support A2A, to support MCP, and also more deployments in the JVM space. And the way I would pitch it is, as Steve Jobs said, agents for the rest of us who are Java JVM engineers, right? So you don't have to worry about building entirely new stack. You can simply start with Arc and then progressively increase the complexity with Kubernetes and things like that.
All right, that sounds like a plan. So we're looking forward to follow your progress in the community.
Thank you.
And wish you a lot of luck with Elmos.
Thank you so much, Alexei.
Thank you.
All right, pleasure.